Flame emission spectroscopy for the AQA students. So why do the metal ions produce colors? Why do some of them produce colors when you put them in the Bunsen burner? Well, this is the reason. When you heat up an ion on your roaring blue flame, electrons become excited. So, pardon me, if you imagine the electrons start here, this is like the ground level. When they get excited, the electron jumps up and gets promoted to a higher energy level. And then the electron will drop back down to its original level. They will transfer energy as light. Now that energy will be dependent on this gap. And each metal ion will have a different energy gap. So once again, the process is three steps. Ions get excited by the heat and they promote to a higher energy level. They then relax back down and they transfer energy as light. They emit light, which matches a particular wavelength depending on the energy gap. If you do physics, obviously you know that the energy gap is equal to Planck's constant times frequency, which is Planck's constant times speed of light over wavelength. But that's way beyond what we need. The important thing is that colors arise from electrons being excited, relaxing, and releasing energy. Now, if you pass that light through a spectroscope, you can detect different wavelengths of light and produce what's called a line spectrum. Now, these wavelengths that are emitted by an ion will depend on the charge, so whether it's +1, +2, and the electron arrangement. Now, no two ions will have exactly the same charge and electron arrangement. So therefore, different ions will emit different wavelengths of light. And that's what I was saying by the energy gap being different. So they'll each make a different line spectrum. The interesting thing about the line spectrum is that it tells you all the colors present in that compound. The intensity of the spectrum, so how intense the color is, will show you the concentration of the ion. So if it's a deep red or a pale red would mean there's less of it. And you can use these to identify ions and calculate their concentrations. But that's not really going to be the focus of GCSE questions. GCSE questions will focus on, on this. Can often come as a multiple choice question. Flame emission spectroscopy is essentially a flame test carried out by a machine instead of a person. So this is very useful for identifying ions in mixtures, because obviously I told you when you do a flame test, you don't want anything to be contaminated because one color will mask the other color and your naked eye cannot see it. So instead, if we use this flame emission spectroscopy technique, we can see that if this is your mixture, your solution, and it produced this spectrum, and you compare it to X and Y, if you have an individual data for X as a reference and Y, you should see that when you put these two together, they form this, which means the mixture is made of X and Y. So that means that if you have a data book and the computer will have loads of different reference spectra for loads of different ions, when you get your mixture, the computer will automatically detect which ions have been combined to form the mixture. Often this will be a multiple choice question where they'll give you this one, then they'll give you a bunch of these and ask you which ones they used to make it. So just match up the lines that they go exactly in line. And then they can ask you for like 2 marks what advantage the machines have. So chemists often use instrumental analysis. So instrumental means using machines, such as the flame emission spectroscopy, instead of doing the flame test by hand. So what's the advantage of the machine? Firstly, it's very accurate because it can detect even the smallest traces of light. It's very fast and can be automated, and is very sensitive to identify even the tiniest amounts of substances. So sensitive, fast, accurate. Just learn those 3. If we look at it one more time to conclude, we can see some applications of where this is used, instrumental analysis using machines. So you can check the safety of a product. You can check emissions that are produced during a manufacturing process of a company. You can use it in healthcare to analyze blood or urine, or analyze the titanium in your hip to see how much titanium is present, if it's still in a good condition. And environmental agencies can use it to analyze pollution in air. The main thing you need to understand, as I said, is the advantages. So accurate, fast, and sensitive. The disadvantages, however, is that it is very expensive to set up in terms of running costs as well. It'll require people to have special training, obviously, to use the machine. And you can only really use it if you have known data of references. So if something comes up that's not in the references, you will not know what it is. This is a summary of how it works, about how you heat the sample using the source. The light given out is passed through a spectroscope. The output is in a line spectrum that's analyzed to identify the metal ions and their concentrations. And here's just an example of hydrogen, mercury, and neon. Okay, so if you're monitoring for mercury, which is dangerous and toxic, that can build up in the body, you could check if any of this is present in the water, for example. With that, that brings an end to the AQA topic on chemical tests and analysis. So I will see you next time. Thank you.